Thanks for coming. You've got to remind me of all the bits and pieces that I forget to say. So, emergency exit, hang out there, go left, and you go through the exit door. Toilets just here, just down that little corridor, 20 meters away. And if that's really busy, then you keep going, and there's more toilets down the far end. Very much thank you to the warehouse group for supplying heaps of beer and
hopefully pizza soon.
Yeah, maybe pizza soon. And providing a pretty excellent venue. Hopefully, what we need to do is find out, get some feedback on the venue in terms of location, how it suits people, and parking, and So hopefully, we'll get some feedback on that over the wee while. And what else have I forgotten? That's about it. So what we've got presenting today, we've got Max, myself, and Michael. And who hasn't turned up, who I thought might turn up tonight, was also Mark Derrickett. So just a quick thing there. Our first presentation will be on Maven tiles and composition.
That's the one.
Yep. And one of the things that we should say is that Mark Derrickett and Richard Voles are the main contributors / maintainers of the Maven Tiles plugin. And also Michael McCullum here, he taught me Maven composites, I don't know how many years ago, a long time ago. And I believe you were the inventor of the idea of Maven composites. And one of the reasons why this presentation is interesting and good is because Mark Derrickett has this illegal argument podcast. And one of these podcasts, he was interviewing the guy who's interested, or there's quite a group of people who are looking after Maven 5, the next version of Maven. Anyway, this guy, they did a lot of talking about BOM and no talking about tiles or composites, which I thought was really interesting and weird, because like I'm not a BOM guy. I'm thinking you're not a BOM guy, right? And
BOM import scope.
Sorry?
The BOM import scope.
BOM import scope?
Doing import scope BOM to pull in dependency manage.
Yeah, adding a BOM and that gives you the versions, right? So like I'm going to say we're pretty non-BOM people, anti-BOM if you like, and yet we've got Spring who's pushing their, Spring initial, blah, blah, blah. So we had the little conversations. So there's quite a different view on this world, and from my perspective, these are really important toolboxes that people need. And I think this is when we had that conversation, Max, we thought yes.
Yep.
If you don't have this, then this is about driving reuse in our builds. And I'm not going to probably say too much more because it'll come up in the slides and we'll discuss. The other thing I was going to say was there's pretty much no rules tonight. So you've got questions, just fire them out. And you don't need to wait for us. We'll probably be talking and stuff, so we might not see your questions. So just ask it. Don't hesitate. It's not rude. We won't be offended at all, especially you, Seb. I guess there's two Sebs, but especially that Seb over there and that Hitesh over there. But yeah, fire your questions out. Don't wait. Not sure how it's going to go for you online people. I will try and watch stuff and get people going on. And I guess there's a chat channel here, so I just better admit that person too as well. So yeah, unless anyone else has got any questions, we can kick on. Is there any questions at this point? Any questions from the online people? Are you letting people in? Are you admitting people in? No, in the chat.
Oh, Rob, I'm doing that. Yeah, Andrew Lindsay.
Somebody's doing that?
Andrew Lindsay here. I'm letting people in. So.
Oh, brilliant. No, yeah. That's excellent.
No problems.
I thought I had a magic mouse for a second there.
No, I'm the magic mouse.
Awesome. Okay, now are there any questions from the online people? And if not, just to be honest, I think you can just probably unmute and interrupt as well. So no worries with that. Okay, let's go.
Let's do it. Yeah, so as Rob said, just feel free. We can hear you guys pretty well. So if you have anything you want to say, just put your hand up or just interrupt us, and then otherwise let's crack on. So Rob gave a pretty good sort of elevator pitch around composition and why it's good. So we want to promote reuse, want to promote modularity, and we want to promote life cycling of the smallest level of dependency, I guess. So who here has learned a little bit about composition in the Maven world, and who here has used tiles? I know a few of us have used tiles in the warehouse group. Has anyone online used tiles before or familiar with it?
Yep.
Cool. Cool. So
yeah, a little.
Nice in there. Thank you. So yeah, like the basic idea around composition, I guess. I'll try to put it in layman's terms. I know you guys probably have done a lot around it, and I'm a bit heavier on the tiles in this presentation, and less so on the general Maven composition. But the idea, as I see it, is that rather than managing a common list of dependencies across multiple projects and dealing with the tax of keeping these all up to date across these multiple projects, especially with our kind of ever-expanding suite of services that we have to maintain in this microservice world that we, starting to dabble in more and more, it just becomes quite a taxing thing, right? Especially when we've got these when we've got lots of different services and we've got lots of common different dependencies across these services, it can become hugely taxing to manage these across all of them. If there's an update for a library in particular that you need to make, then it becomes quite annoying to have to go through across multiple projects, keep them all up to date, bump the version, and then do multiple individual releases for those different projects. So this is like the most, this is like 30-second thing I mocked up in Google Sheets real quick, and it's basically for composition. We might have our framework dependencies. So at Practive, by the way, I work at Practive. Michael here works at Practive. So he's a principal SRE, and I work as the lead engineer there. What we might do and what we do in Practive is we have composites to manage a lot of our framework dependencies. So we're using Micronaut quite heavily at Practive, and so an example for how we use it is basically pulling in all of our framework dependencies and testing composites as well. So for testing composites, the example there might be that for all of our JUnit-based dependencies, we use JUnit, we use Rest Assured in certain circumstances, Mockito, bunch of these dependencies, right? So we can keep these individually life-cycled and managed. In layman's terms, I guess, it turns like a massive dependency tree into something that you can bundle and manage individually. Any questions so far? Jump in at any point.
So I'll just leave you on the slide for a second here. So this is the guts of what a composite is. Composite is essentially just a Java project with no code. All it is a POM with dependencies. That's it. So we bundle it as a jar. And I thank Michael for pointing me out that you can bundle these things as a jar. But you bundle it as a jar, and the jar's got no code in it. But what it is, it's got the POM with the dependencies in it. So we're grouping. So what are these ones? They're all logging ones?
These are logging dependencies here.
Yep.
Yeah. So
essentially you've got a project, it's got a POM, it's got the dependencies in it, and it's got no code.
Yeah. So composites are basically, it's the same deal as like when you bring in a library, right? You might choose to bring in a library to do, say, to handle how you do client calls between applications. And oftentimes you'll bring in the, entire Apache Commons library or something that you just don't want. Composites are similar, except they just don't provide any code. Their sole use is to basically bundle these dependencies and then bring them as singular dependencies. So in the end, when you calculate your effective POM for Maven projects, you're still going to have all of these individual dependencies when it's built. However, it's just a much better, way less taxing thing to manage and look at and just deal with over time.
Sorry, Max, just before you go on that slide,
yep.
You're going to say something?
Yep.
I was going to say that just note the version range there. So we've got a version range on the right-hand side,
yep.
2.20 to 3. So a lot of people aren't using version range as much, but basically that allows you to actually roll out a composite, if you like, and you can choose it to be a non-breaking change, right? So as a bug fix, versus actually let's bump the range, and that allows us to grow with microservices that are still running on an old version of, say, the logging, and some newer ones that are using a new generation of the logging. So things like that. So,
so it allows you to roll out stuff, change piecemeal, which is good and bad, right? Because you kind of want everything to be running the latest and greatest, but at the same time, if you need to deploy a new system and a new feature, you don't want to be held up because of some legacy code, which doesn't necessarily work. One of the important things to note is that we use ranges everywhere. So we use ranges here for this, and we use ranges here to define the view and the lock square, which means that you can only resolve in your Maven tree that singular version. You can't introduce anything else. And what that means is the build will fail if you try to introduce any other changes. So if you've got a conflict, you get a failure, and you get a failure at build time, not at runtime. When if you don't have the square brackets, and you don't use ranges, you could get any old version because Maven doesn't care. If you don't use ranges, Maven will just result a version, and it will try to give you the one that you want, but it will just depend upon how the tree results and where the transition takes to what you get. And that's especially true if you pull your dependency stuff into parents and you try to use import, the import scope for dependencies and use bombs and pull in dependency management. You don't actually have deterministic dependency resolution, and it will change at runtime. And so you can end up with random things happening. And you do releases, multiple releases in a row, and you get different dependencies coming out, which I've seen.
Yeah.
So
That's a good question. Generally, I don't do any testing in the comps. But you could, especially if, for example, if you had a composition, say we've got this logging composition, and we want to upgrade to the latest version of the new version of yourself, and we find that works for 80% of the projects, but there's 20% where it fails for a reason, right? There's some dependency or something. So what you could do is you could add a test into the composite that says we are testing to prove that this condition is true or false in terms of what's building. And then you'd know that if the condition when you upgraded the libraries broke that condition, then it was a failure and it wouldn't be released. So that would be an example where you could stick a test in to validate the composition. But generally, you don't have tests because you're just composing the libraries together.
Yeah. So exactly, because we're composing libraries, usually either internal or external libraries, usually we can defer to the external library's own test suites for their kind of stuff that they're in their domain that they handle. But generally for our things that we build in and we compose, we're going to have tests on the individual project level as well, right? So that's where the majority of the testing is basically sits. And then everything else from a composite level, it's all about really just packaging it up and shipping it as a unit. Cool.
One question around the version ranges. How do you define which version to pick from that range?
So if you've got a square bracket on both sides, it's a fixed single number, and it has to be absolute. So it has to be exact. But generally with compositions, you're trying to define a fixed tree. So you literally specify the fixed version and that's what you want to get. So if you want this data, you might say
This.
so that is right, so 141 only have one. You can't have anything. For
When you say we can't have anything else, what means?
so if you include this composition in your project, and any of the other dependencies in it, try to put in 142, that will do, and that will fail.
Right, okay. So there's a bit of dependency between all the other kind of components we have in there that rely on this. So do you expect these to be kind of independent?
So I expect these things get into
Okay.
So what we're saying is that these things go together, and life cycle these things, and we break it up in this definition. We say we want to use this as a definition of all of our processes, and it's consistent.
All right. So the version is essentially defined by other kind of dependencies.
And the way to do that, the simplest way to do that is to run a reactor with what called code is, make changes to this, try and build a dependency, There's nothing better to happen. Because if you're moving fast forward in but we do it fast because we know these things. For this one, it's an open range. There's certainly thing that it's two different the same from to like when you put into the but then when you get the latest version of that goes within that two contract. If you want to do a breaking point, then you change the select the and you let one log back, drop log back up, and just what you do. So drop log back up and put in block to the root, then you're right. And then you simply pull it in and what's really important if you're not familiar with ranges and running ranges is that this less than 3 will include this. So if you go and push it to a snapshot and pick that in your tree, they will get included because 3 snapshots is it's a simple solution to that is that you're going to be moving your project to a start.
.999.
Right. Yeah, but when you release them, just leave them to zero. If there's no zeros, then they will and maybe become that's the biggest reason why people don't use ranges because they don't actually use that one. But it's not, it's just
What a simple solution for it, yeah.
if you always do never use zeros in your versions and you have to switch.
So we basically manage all of our rollouts through version ranges, and the general rule of thumb is, as Michael mentioned, is if it's a non-breaking change, if we're fairly happy with it and we know that it doesn't introduce any new config that any kind of consuming application needs to deal with, then it's just generally just going to roll out, for our CI pipeline. It's only in the case where we introduce bits of configuration or something else that dependent libraries might care about, where we would bump the version range of that composite or of the library or whatever we're working on, and then handle it manually, basically, because it requires a bit of manual intervention in that case. But everything else just rolls through as long as it fits within that version range. Cool.
When we pull it in next to us, another library that we had. But most often when you pull in the third-party library, you need to do it. So it's the point of view of third-party library, and because I want to have the logging stuff, I'll pull in the logging composite and the common things that are concept, and exclude the things that you have to be external because you want to control the life cycle of those external things being pulled into it. The same reason you build your own document is with third party because your own version of
Apparently a bit tricky to hear people's comments from the floor, so we might just repeat them at some point if they're, it needs it. Right. We do that. So the question was that for production releases, you take it that we would fix the version numbers so it doesn't just roll through for all cases.
That's a good question. So in terms of these compositions, we're talking about versions of data libraries, and when you do it too, you're packaging those up. Right? So you package those up into a wall or into a document. Okay. So you've already fixed those versions by the virtual doing it, and the life cycle of that wall or that document has a version, and that version is a version time for this thing. And because we're building it Java, and you put it dependency in, we've got the jar, but this is the version of this which is called the blue one, then you water the bottom, and you can even see if you don't know what you so that's fixed in that. And if you're thinking the bottom and you do the water, and you'll move that bottom one, so you've always got that water to the district what you use. There's no need to go and fix. There's a couple of things that we do. So at build time, so if you look at this region here, that is still a point. So most often we have our own PDOs, and then at build time, I'll run the balance plugin which will go through and update all of these ranges and put the result in the right one. What that means is that any project which is released, it can be easy to be fixed with that low down because you can't go through and go through it. That's what we do. So you always sort of definition of what you use to build that. And that's important. And that's just the balance plugin you can use.
Yeah.
It goes a bit like
So that one's quite good. And generally, my rule of thumb is to, if I've ever produced an update that I'd expect if I'm sharing code or whatever, and I expect someone to be on the same version as me. If I'm sharing code or collaborating on a PR or something with somebody else, I'll do this where I'll specify the minimum possible version just so that when they're doing a build, they're sort of guaranteed to need that latest update. It'll get pulled in as a dependency so that they'll be on at least at the same point that I am when I'm running the code. It can take a while sometimes for Maven indexing to kick in and pick up the latest version. So generally we just do a minus update when we do our latest Maven clean verify or install, and it'll make sure that it re-indexes it and pulls the latest version that's specified. Otherwise it can be like, oh, this dependency hasn't found because your local index hasn't been updated. Yeah.
Yeah, I tend to actually run with a whole day cache time and only updates my user.
Yeah, I mean, if you run -u, so minus update on Maven anyway, it's guaranteed to re-index and pull everything as well. But it is kind of good as like a sort of behavioral practice, I find, to say I bumped this version. You can see in my change that I bumped this version.
So
and
you
that
run
generally
the balance update when you're producing the commit.
Exactly.
Yeah. So you can do that anytime locally and then commit those changes. That's good.
Yeah.
When I was using the Maven plugin before we're doing full-on continuous delivery, using the Maven plugin for release as part of that commit, which comes with the version, would do a balance update. So you always have this committed program and then
Yeah. Cool. Couple questions. So the question was, what about the supporting ID for the version?
Supporting version in IDEs.
In the IDE.
Yeah, it just works. It just works. And it works really well in clips, so especially when you plug a clips in.
Nah.
Not bandwidth.
I hear this every day.
Projects and a clips are all meant to really good. If they match the range and if they don't match the range.
It's the same deal for IntelliJ, right? So if you've got multiple modules open up in IntelliJ, then you're going to be using the versions that you've got in your editor, as opposed to grabbing it from the versions. Not if the versions don't have. It's got to be within the range. Yeah. But yeah, both editors support that one, I think.
Let's say Westwood House. We have already do something. That we won't actually
So the question is, do we have a plugin that can give us the resolved list at build time?
just logging.
Yeah. So one thing that I do is I run the dependency plugin, and I do the dependency tree and the dependency list, and I those.
Great.
Okay, Houston, we have a problem.
It's bound to be one.
Hey,
There's always
you're
one.
still presenting on this side here.
I don't know if that's updated or not. Is it?
No, looks like it's not. But back in the bad old days, if you like, or the good old days, depending on how you put it, if we had to hot patch something in prod, we could go and look at the artifact and go, oh, this is and, you know, you could emergency tweak that jar that you needed to. But in the days of CI/CD, it becomes less of a desire, less of a thing, right? So I'm not sure that I'd even be more worried about that now. Yeah.
There's a downside to it in that those files that get generated. I think the files that get generated end up having a timestamp in it, which means that if you're rebuilding the same jar, it looks different. It doesn't have the same check in.
Right.
It's the same, which is a bit annoying.
Right.
And that's one of the reasons for turning off, and you'll see in my example later, some turning off timestamps in Maven default metadata and jars.
Right. Okay. Yep. Now,
Question? Yes. And
Just booted off the network.
so yeah, you know, network's being antisocial for Max. I think I've got my mic on so people can hear us. They're not listening to a void. I think what that means is that how far away are we from the end there?
We're quite early on, actually.
Yeah. Okay.
Do you want me to send you this? Because my wife, I think the TWG.
Yeah. Okay. So should we do a little mini break here for 1 or 2 minutes, or should we? What are you gonna do?
Send you this.
Oh, okay. Yeah. That's just a link. All right.
Unless I can get back onto the Wi-Fi. Do they turn off guest at a certain hour?
No, it's got a max filter. It's like max. No, sorry, mate. If you fire me that link, are you firing me the link? Okay. Hold on. We're doing what? You're doing a hotspot. Your own hotspot, are you?
Mm-hmm.
Go find a beer, people. Any questions from online? I think you're all. Oh, hang on. What's it now? Just lost audio. Oh, it's fine now. Okay. Audio from Rob's laptop is better.
yeah, that's what I like to hear. How about that? No questions from online?
Okay, so Max
It was actually
is
it was
firing
just a little bit
again.
hard to hear about the some of the questions from the floor, unfortunately, or the comments from the floor. So
Standing around.
yeah.
Yeah, I can do both.
Speakers. What do I want? I want the mic volume.
Mhm.
Are you? How's that? So mic on my side. You're going to present on your side.
Yeah.
Okay. We've got about 30 seconds to tee off time again.
Wouldn't be a presentation without it technical difficulties.
These are the challenges.
Yeah. This my struggle, actually. Really, it never really works, does it?
Okay.
Right. Can people see my screen? Let's see. So I'm on 4G, so hopefully the quality is okay.
Contact. Yeah. Sorry. Yeah, we're back on. Rebel people at the back, we're going to carry on-ish. Yep. Sorry to ask you the question, but obviously we haven't talked about the other alternatives like parent POM, inheritance versus composition, right? Because that's fundamentally what we're talking about, right?
Yeah, so we do that. We do that.
I should move my laptop closer to Michael or something.
Yeah.
We'll move to the Michael. Actually, I'll just
Standing in the light.
where do you want to be? In the light.
Walking around.
This is one of the world's biggest microphones.
Maybe a bit further away. Hey, they can see me. So yeah, I guess the alternative, yeah, as Rob was saying, if you're not doing compositions, how do you share libraries across your projects? And I guess if you read the Maven book and you look at all the examples that you're going to find online, people tend to pull their dependencies up into the parents, and they have this parent-child hierarchy, which is kind of weird, where there's a parent project which has all of the dependencies for everything in it, and then the children all use it and then don't define version numbers, but generally you have to include the version itself. And there's problems with that because the parent ranges don't really work very well for parents, which means you have fixed definitions of your dependencies coming from the parent. And if you try and mix and match libraries with transitions, then the resolution to those parents might be different. I.e., if you've got a good picture, maybe jump back to your original picture.
Well, you can stick on this one. What I would say is that microservice A and microservice B are quite different. For example, one might talk just queues and one might be just REST. And so they have quite different.
That's true, but that's not the point I was trying to make.
Okay, sorry.
So the point I was trying to make is that all of these things here have a different parent. And if that's a single parent, because they all inherit from the same super parent, which is like the parent directory, and these are in a tree. And the dependencies are all defined in that parent, and they've all got different parents. What happens when this project and its library transition to different parents and they have different versions? Which one actually wins the race, especially if you don't use ranges? And the answer is you don't really know. It depends what order you stick these things in. And so what it means is that you can have 3 projects which all use this dependency, but because some of them have this one in front and some of them have it after, you completely different trees. And so it's actually impossible to maintain. And especially when you've got a real world project, when you've got 30, 40, 50, 100 artifacts, you can't maintain it, you can't understand what's going on. And you'll go and add this new third-party library to your microservice, and all of a sudden everything stops working and it crashes. And if you're not using ranges, it probably crashes when you try to run it, because it suddenly says, actually, I'm missing this class, which you expected to find. So that's why you can't stick it in the parents, because there's no nice way to define the relationship where you actually strangle it down to the one dimension where you pulled it back to just that composition where everything is defined the same and it's restricted. In terms of the import scope, it basically does a similar thing. They've taken that parent pattern, they've tried to pull it out of the parent and let you do an import, but you end up with the same dependency management structure. And you do get more control because you've got the version range, so you can end up with consistent things turning up, but you still have the issue where the dependencies are in the dependency management section, and the way that they inherit and the way that they're determined is again affected by the order of stuff. So it still ends up being broken by just not as often. And I just feel that if you were to look at the project object model, which is the model that Maven uses to represent projects, if you turned that into a class hierarchy and you said these things are classes and they relate to each other, would you use that model for defining anything? And you wouldn't. If you're doing composition, you'd pull it down to the bottom, and now you'd never inherit it. Yeah. The pattern, just if you just look at it like that, and you go, actually, this is really ugly, I shouldn't do that. And so composition is very natural if you look at it that way, especially for a Java developer.
So to reiterate that in slightly different wording, in coding, do we use inheritance all the time, or do we prefer composition? Right? We generally try and prefer composition for good reasons, and this is exactly the same. And the other thing, every now and then I talk to you and we go, people don't put enough effort into managing their dependencies, right? So we put all this effort into source main, we put a little bit less effort into source test, probably wrong, and we put a little bit less effort into managing our dependencies. Probably wrong, right? Long term patching, all these sorts of things. So I think, what the issue there is, we need to try and think about and put as much effort into dependency management as we put into source main, basically.
Yeah, normally what I do is I'm approaching a library that I haven't touched before. I delete all the dependencies, and then I add them back again until firstly it compiles, and then it tests. Well, then the tests compile, and then the tests run, and then I stop and I leave everything else up.
Yeah.
And nearly always that's half of what's there, because people have an issue and they add stuff. Just keep it.
Yeah.
And never take away.
Yeah, what we see is quite the opposite of what you'd get if you got like a Spring Boot initializer, right? It's just boom, boom, boom. I just tick these things. You've got the world coming into your app, and myself and yourself are probably going no, but a lot of people, maybe even the majority of people, that's how they live and that's how they roll, right? So there is a different mindset out there, and might even be the majority mindset.
I think so, yeah. No, it's definitely something that if you're just starting off and you're creating a single project, and you're not wanting to scale these dependencies across multiple servers and maintain them, then it's not the worst option to just pull something from an initializer and just get rolling with it, right? But when it comes to scalability, when it comes to managing these across multiple services, the composition becomes a really handy ally, I would say, for managing all of that noise and all the struggles.
And also for when you're starting a new project, just being able to add things. And I mean, and that's why the Bootstrap starters are quite good, right? Because you just add that one dependency, you get all the stuff that just works. And you want the same thing, but you want it to be clean and simple, and based on your standards of what you've decided to do for your project.
But you want to keep it lean, right? So only use what you really need.
Yeah.
The other thing, though, is question turning into question. Do you actually recompose kind of third-party stuff, where you kind of go out and say, actually, I want to have a lean version of logging or something, where you just kind of pull in stuff and actively exclude stuff as well?
Absolutely. Yeah. So compositions nearly always exclude. So I do the same process, right? I exclude everything and I pull in the stuff that I need to make it work. So if you like pulling in, what's a good example? Like using Stackdriver, for example, pulls in a lot of gRPC and a whole lot of other stuff. And there's a lot of stuff in there which actually you don't use. So you can pull a lot of it out and just bring it down to the core stuff that you actually need.
One of the handy offset of that is being able to extract those exclusions down onto your composite level is quite handy, again, because you're not muddying your actual project with all of this exclusion noise, right? You can manage these quite fine-grained concerns on a level that is abstracted away from the actual development, I guess. And as you build your composition, you kind of, like you say, it's all about creating an ecosystem of these modular, reusable things that are lean and that we bring in when we need them, but don't bring in all this other crap that we don't need, right? So the more services you create, the more composites you create, it starts to feel quite natural starting off a new project, just being like, okay, I'm building a REST API, I need my framework stuff here. I want to do some contract testing for my REST API side of things. Maybe I'm going to bring a REST assured, or I'm going to do it on another layer. You start using these building blocks, and then you sort of contribute to this wider, almost like internal open source model of these composites for these dependencies that you use, and that creates consistency. That creates basically a good environment to work in.
Yeah, that's another question I have. Is, do you share these kind of lean versions of your own stuff? Is there a way to do that? GitHub potentially, like.
Yeah, well, I have a whole pile. Well, they're a little bit out of date because I haven't been touching them recently. But I have a whole pile of Maven Central for logging. Opinionated, right? My opinion of how these things should be done in terms of REST, in terms of Jersey, in terms of Spring, in terms of logging, in terms of testing.
Well, as you mentioned, building blocks, and does it mean that you need to build the building blocks before you can start building anything?
No, and it depends.
How much time that takes.
Yeah, so the question is do you build the building blocks before you do the building? And how long does it take? And that's a really good question. It depends. I mean, if you're in, depends what you're trying to do. If you've got a little project and it's a tiny project, it's probably not worth it. But it's easy to factor these things out, right? So you want to start, you always want to make it work first, right? There's no point in going and building this magical composition that's perfect and then going to use it and it's wrong. So you always start in your project and then you factor the things out when it makes sense. And if you're using the rule of 3, then you wouldn't do that until you've duplicated it at least twice. Right? So you've got 2 libraries, they end up using the same dependencies, and you're like, okay, well, there's a pattern here. Pull the pattern out and reuse it. Yeah, because otherwise you end up with twice as much work. It's like magic number refactoring.
Process, you kind of start realizing it. You kind of go down on that. Then
and you want how you do it, how you're using it to guide how you factor it out, not overthinking it to start with, just doing what is needed.
And it also means that if we say we have a composite or whatever you want to test, try out a new testing library, it doesn't mean that you go to the building block first and you say, hey, I want to start using this or trying this out, so let's produce a new release with all of this, and now all of my apps have this dependency. You can still manage your dependencies on your raw project level and try new libraries out. And then once you're comfortable where you're at a point where you're like, oh, I've used this across a couple of projects, I'm going to roll this into my testing composite and then start using it across all of my applications. Yeah.
Yeah, so I think to reiterate what you're saying there, Igor, you're starting, and then what you're doing is you're looking for that. So you're looking in your POM and using those, hey, there's a lot of dependencies that are repeated here, type lens. And the point here is that a lot of people are not doing that. I think that's the point, is that a truckload of people just, works and they're moving on and they're not looking at that POM in a sort of a critical way, saying, where can I drive reuse? And the reason for doing that is because I'm going to do 10 of these microservices and they're going to look long-lived. I'm going to have to maintain these dependencies over time. So your payoff is 2-3 years down the track when you've got 10 of these things all. Yeah, but you start off, you start off with a big POM probably, yeah. Is that fair enough?
I think so, yeah. Any more questions, I guess? There's a bit more to go. So I guess tiles is the next concept we're going to talk about. So, I mean, we've talked quite at length, I guess, around like the struggle of maintaining just pure dependencies over time, right? There's not much logic to dependencies, like bring in a dependency.
Just check that they can hear you from, because that laptop's got the mic.
Can everyone hear me okay?
Or do you want to just go up there?
Yes, that's working well.
You got sound coming out of this one?
In theory.
Yep.
Okay, cool. Well, now we do.
Okay.
If you were talking before, we couldn't hear you, I think.
Right. Yeah, so like...
Don't stand in the light. Goodness. yeah, need one.
So yeah, basically, we've talked at length, I guess, about the length or like the problems with managing just basic dependencies over time. It can be quite cumbersome to just bring in libraries and manage them across multiple projects, and it becomes even more labor intensive when we do things like try to scale plugins across these multiple projects, right? So there's a whole bunch of Maven plugins. I'm sure lots of you have used a bunch of them. At Practive, we use them incredibly intensively, and we've got a lot of examples, a few examples to show around how we use them. But with that complexity comes the same problem we need to solve, and it's not something that Maven out of the box has a pure like native solution to solve. And Tiles offers a solution for us that kind of gives us the same benefits that we get with composites, but with plugins. So this is actual logic, build logic, lifecycle logic all around Maven, all around the different Maven phases, from generating your sources to generating your classes to building and doing whatever you need to do. So we've built a quite extensive ecosystem around this concept. Michael's going to talk a little bit around some of those concepts, and he's got a few slides that he'll share. And then I'll come in with a few examples around the kind of where you can go with this concept and where, and like some examples that we're employing this. So yeah, over to you.
I'm gonna switch to the next. So has everyone used Tiles? No? Do you know what Tiles are? No? Okay. We'll start there. So what are Tiles? Tiles are just little snippets of Maven configuration. So it's basically a POM with some of the elements that don't work. It goes in an XML file called tile XML, and it gets released like an artifact, goes into your artifact repository, and you can resolve it. And there's a Tiles plugin that does that resolution, and then it has an extension which is part of the Maven lifecycle, and it resolves those tiles and merges it into your current project. Because the model in Maven is single inheritance, it does that by manufacturing parents. So it builds an artificial parent hierarchy based on each of the tiles and merges those snippets in. So it's like you had old pilot parents, but you don't need to have parents. And if you weren't using tiles, then you would use parents in this way, probably. But it just does it automatically from snippets, and you can reorder them and do various things. Yeah, they have their own life cycle, so they're their own projects, so you can manage them, you can version range them, you can do major version bumps and break things and not break people when they're using it. And because you're using version ranges, you get changes automatically. So it's easy to roll out consistent plugin configuration for a number of projects and upgrade that when there's mistakes or improvements that need to be made.
So can you just explain the parents thing again?
So each Maven project has a parent, well, should have a parent.
I'll have a crack at explaining that. So one of the things that's interesting is the tiles thing. Is a slightly interesting hack, if you like. You could describe it as that. And the concept is there that tiles aren't a thing that's built into Maven. So the tiles plugin, it comes from Mark, Derek, and Richard. They're maintaining it. And what it does is it's trying to reuse plugins, the plugin section. Now, the way to get it in there into our POM is actually via an inheritance thing. So it basically messes with the POM to get, it inserts an inheritance, a virtual parent. That's a great explanation. So that's kind of the way it works. And it kind of has to work like that because Maven doesn't have this thing naturally. So the tiles plugin is the IO repaint one we're using. It's using this virtual parent in order to achieve this goal.
Comes on the next slide.
Yeah.
So it's a most configuration and properties. What else can you run? Can you run the profile?
Yes, you can do profiles. Yeah. You can pretty much do anything, but you can't define extensions because it happens after extensions are initialized in the lifecycle. But
So,
you shouldn't do everything.
Yeah, exactly. So I think the point is you can do probably anything, but you shouldn't do anything in the sense that, well, I think what we would probably say is we use it to drive reuse on the build plugin section. So if you've got something in build plugins, then that's a case for, hey, that could be a tile. Can you add dependencies in there? Yes. Should we? Probably not, because what we're trying to do is say, use composites to drive reuse of dependencies, use tiles to drive reuse of plugins, build plugins.
Yeah, and the reason for not doing dependencies is because you've got synthetic parents. You can't guarantee the ordering for the same reason that you don't stick dependencies in parents otherwise. Yeah.
You might not be able to do exclusions as well. I can't remember. I can't.
Yeah, that might be true. The exclusions might not work because of the time in the life cycle when it gets resolved.
Yeah.
Yeah.
Did that? Yep.
So here's a trivial example of, can everyone see that? A trivial example of a tile. It's literally just a project and a Maven jar definition, that's it. That's funny. So you can't see it.
No, I said yes, and that's just true.
Can we make it bigger?
Sit beside the mic.
We'll share the slides.
Yeah.
Yeah, don't do dependencies. So you could, in theory, stick dependencies into it, but don't do it. It's bad.
So it's a fragment essentially of a POM.
Yeah.
And it kind of gets embedded in.
Yeah.
It's a plugin itself.
It gets merged.
Gets merged.
Yeah, well, there's an extension. There's a plugin and an extension. So it takes the sections that you've got here, and then it walks through the model and it injects things. And it does some interpolation of some things as well.
Right.
So some magic in there. And it's all groovy, nasty magic. You don't look at it.
But I think that's a great explanation. It's a fragment. And one of the cool things about that is that if you've got something in build plugins, pretty much copy and paste it into your tile.
So it's an automated copy and paste
Yeah.
in the right position where it's supposed to go.
Yeah.
Awesome.
What use tasks? I mean, we've already been talking about this, I guess. You want to reuse these configurations. You want to share them across all of your projects. You want to be able to create a new artifact and say, I want my build lifecycle to work the same way as all of these other ones. That means your POM is very small. It doesn't have miles of plugin configurations that vary over different projects. It's always the same, works for everyone. You can lifecycle it with the versions and roll it out. And I guess one of the important things also is that if you've got these projects and you've got these definitions of the tiles, and you get at a high level what tiles are, then you've got these names for things that just work. And when you're starting new in a project, you don't need to understand everything. And if those concepts are hidden and they're simple to read and there's just a few lines, you can say, oh, I see that this project is a REST server. And you can see those patterns immediately in this small list of tiles. And you can go, I know what that is. I know how it works like these other ones, without having to go and understand pages of plugin definitions to see how it actually works. So you can reduce that cognitive load for people until they get up to speed and they want to look deeper and understand how it's actually working.
So this may be in later slides, but how do you kind of refer to which tiles to use in which POM in a POM?
Yeah, John.
Cool. I'll wait for that.
Yeah.
Thank you. Lead over.
Perfect. We didn't set that up. So this is the project. It's got your standard GAB at the top, and you've got the tiles plugin here. I left out the parent, and the parent would actually define that the extensions on this is enabled. So if you have a plugin with extensions, then that extension gets pulled out and added to the life cycle of the project when it gets built when Maven initializes. I missed that out here, I just realized. But what happens is that the extension is initialized in the life cycle, and before anything else happens, it will go and it will read this list from the plugin definition, and it will go and download these tiles, resolve them, and then it will merge them. It will create parents from them in this order. Is there a reverse order? Normal order. Yeah, I think normal order. Yeah.
So again, you've got a version range in there.
Yep, version ranges.
Who defines which version to pull in?
I do. This is my project.
Yeah, but this is a range. So which one is being actually pulled in?
The latest. The latest.
The latest.
Oh yeah. So this is resolved by Maven, and always choose the highest. The highest that fits within the constraint.
Okay, so but unlike your previous example in the composites, this isn't driven by any other system that defines which version to pull in. So there's no interdependency that says I pull in the sticky tile build version 1 because I need that.
Yeah. Well, so where we had compositions as well, dependency compositions, we still use ranges at that level to pull in the composition itself.
They have the same way.
Yeah.
It'll pull the latest composite and it'll also pull the latest tile, as long as it's within that, falls within that range.
So we jump back to the other slide quickly. So here's a range here. So yeah. pulling in the composite.
This is driven, which version to pick here is, if I understand correctly, is driven by a dependency of this version.
So if I want to include this composite in my project, then I stick this in my project with this version range. And it results in me getting this in my tree.
And the version of the dependency on the right that's pulled in is the latest or the highest version.
This is the composite. No, I got it.
Yeah. So this version range says give me the latest 2 version of the composite, which is this thing being released.
Right. Okay. Gotcha. Cool. Okay. Gotcha. Yeah.
Can I just
That's your space.
We've lost that driver. Driver, where's the screen gone? Oh, go faster. 10%.
Is that USB-C?
Yeah.
Okay, talk faster.
Another driver that is USB-C that we might work.
Yeah, as long as it hasn't run out, then it should work.
Right. Next one.
Just a link, right? Can run on any.
Yeah, so this pulls in 3 files. They'll get resolved as synthetic parents in this order, and that will introduce a bunch of plugins. So here we've got.
And you just pull the latest of one essentially.
Yeah, you just pull the latest. This version gets resolved, and you'll see in the example from the next screen, it'll show you what that looks like. And so it'll pull in all of the plugin definitions from this tile and properties and merge it into the parent hierarchy. Yep. Cool. 1, 2, 3. Cheers. I guess we kind of jumped ahead and talked about this already.
Yeah, that's good. That's
yeah, we already talked about that. So this is a build running, and this is just a snippet which shows the building of a plugin here, and the tiles plugin here is saying that it's injecting tiles into the parent. And it's, in this case, it's not from the previous example; it's another one, but it's introducing 2 tiles. Then it's putting this release tile in as its new parent, and then it does this thing here as the top level parent. So it lists out the versions that were resolved as it's building it to show you what's going on. Yeah, so you can always see what's going on. And it's important because we're using ranges all the time. And if you have large dependency trees and other stuff, and running -u is quite time consuming because it's downloading extra metadata in the background where there's actually no changes, but just tile changes.
Yeah.
Running a -u, doing this first step, killing it, starting again is faster, which is quite good because it already updates this metadata independently. It jumps to the next slide. So given that we know what tiles are and how to use them, how do we write them? What should we do with any things that make a difference? So one thing that we found is that once you start pulling these configurations out, they get a little bit opaque. It's hard to see what's going on in the build. It's hard to understand. You can get the effective POM, but it's quite big and it's hard to really see what's going on. And it's hard to see what's configurable and what's not. How is the plugin configured that you want to use? What's available? So making them chatty is quite important. And so it's always a good idea to put default configurations in, but make them overridable so that you can override them and change them if you need to. That way, it works by default for everyone. In most cases, that's just fine, but sometimes you need to change things. Like if you're doing CDU scans, you might want to change the level that you're filtering at. So you want failures are critical rather than high or high rather than medium. You should always echo what those configurations are and what the current values are, and maybe what the defaults are. You can be bothered.
So just on that, like we have fallen into a bit of a pit in the past, I guess, where we've created tiles but haven't been as verbose as we could have been, and it can become quite hard for things lost in the abstraction, I guess, right? You don't want to get forced into a place where you're like, where is this happening? So this is a really important point, and it's something that it can make it really quite nice, is, you know, echoing out and printing those properties. You know, these are the properties that are being set, and you can override them and do whatever you need. And also just, we even take it to the point of like required files that we might require in our project directory and things like that, for our project structure to be deployable and run correctly. Then we might even start echoing that, hey, this file doesn't actually exist. Things like that. So we get quite detailed with what we report. Yeah.
Yeah, maybe turn the lights on. Dim the lights. Lighting there. So here's an example of configuring a tile. So we've got at the top of the tile, we just define a bunch of properties, just like a normal plot. And then in some plugin, I chopped out all the extra bits, so it's just the important pieces. So you can see there where in the configuration of this plugin, we're using that's obviously wrong. It should match this. Sorry, oh, yeah, that's not. Yeah. So we've used this value here in the middle to define the Docker CPU for this plugin. And what that means is that by default, if you use it, this plugin will use this value because it's resolved from these properties. But if I want to, I could override this value in the child project or another tile, and it would use that instead.
How does the tile composition work?
We'll get to that.
Okay, sorry.
That's a good question. Yeah.
There's a question on
Question online? Question online. So next one tile. Do we have off by one error there?
What? Yeah, probably. I probably edited it for demonstration purposes.
You broke it.
No, I took the output of the thing and then I fiddled with it, so it fit nicely on the screen and I could talk about it.
So this is a good example of the eco.
Oh, Mark said he forgot to come.
Yeah.
I should have arrested him, I forgot. So in terms of printing out what the configurations are, there's a nice eco Maven plugin that some person wrote. Beat me to it, which was good because I don't write all plugins. And it just does ecos, standard ecos. And the standard pattern I use is that I do the name and then the value. Easy. And that'll just print out the configurations at build time. And it's always run in the initialize phase, which is after validate. So it's the second phase in the standard Maven lifecycle. And what that means is that if you've got any tooling that does loading of external property files and other property manipulation, it should happen before you echo it out. Otherwise, you get the wrong information. So that's why it's an initialize. And that's what it looks like. And so it just echoes out the values. So what's important is that when the tiles plugin or the tiles extension does its magic and interpolates things and mixes it in, it adjusts the IDs of the executions of the plugins, and it writes the ID here and includes the GAF of the file. So here you can see that this echo plugin is being called from active tile example, version 7.9 ID show tile configuration. So if you go and look at that GAF and go and look at the tile, you'll find the plugin definition for the echo plugin with an execution ID of this, and that's what it gives you. So you can always see from your build exactly where the plugin definition has come from, which is quite important. You can always track it back. That does introduce some issues if you want to try and override those definitions in your local project, because you have to know that, and that changes.
Right.
Yes. So if you're expecting that someone's going to be overriding it and try to override an individual execution, then you've got to do some special magic, like record this version of something that you can do a replacement with. I try to just avoid that if possible. It's complicated and confuses people. Cool. So composition. That's a good question. Yeah. So tiles are not like dependencies. The way that the trees resolve, it's not. Well, it is transitive, but because of a limitation of way, or maybe the way Maven works, or maybe the way that the extension works, is that any downstream transition, all of those transitions are collected and put at the end, or the beginning, I forget which. And all your local plugins happen after or before. And that means that you can't control the ordering of stuff when you're bringing the tiles in. And in particular, if you have, and this is true of tiles as well, so if you've got a tile definition in your project and one of those tiles has other tiles, then all of those tiles happen after, which means that you can't control the order and stick plugins and override stuff before or after, which is awkward. So what we settled on is a pattern where you only ever do, you either have direct tiles or you use aggregates of tiles.
So you mentioned earlier to kind of that other tiles affect the properties of other tiles.
Yes. So because they're parents, they all inject their properties in order, right? And so the most recent tile wins in terms of setting a property value.
And how do you define the order on these? Again, is
just how you list the tiles. And
okay, so in the POM itself.
Yeah.
With the general clause that it generally probably doesn't matter because tiles are typically orthogonal to each other. You probably don't have two tiles that are doing the same sort of build plugin.
Yeah.
So the intention is that you don't override property.
But tile interaction probably doesn't matter. The order of the tiles probably doesn't matter because tiles are very different things.
Yeah, so if you isolate the scope of your properties, then the ordering of the tiles doesn't matter. And so if you want to share the scope of properties and definitions, across your tiles, then you need to be very careful about the ordering and how you expect it to work.
So for example, you might have a tile that's all related to building Docker images and another tile that's related to all like running Surefire tests, and they're really quite different things, so their properties don't. The ordering don't relate.
Yeah. So, gotcha.
So what's the example of composing? Oh, if you put a tile inside a tile. Oh, okay. So basically saying that I don't think we do it. I don't do it.
Hey Mark, can you describe what you mean by embedding tiles in tiles as something to be avoided? Okay, I should probably listen to this.
Can you hear me?
Yeah, we can hear you.
Yeah, so in the tiles XML file, the tile.xml, you can actually embed references to other tiles by putting a tiles element and then tile and then a gav, similar to what you'd put in your end applications configuration.
Yes.
And that does a transcluded kind of subtile.
Yes.
It's messy as shit, and don't do it.
I do it. And keep watching. That's really good. Don't take it away.
And I think in the most recent release, 2.20, you're actually using an old version. You should upgrade.
Yeah.
We changed the ordering so that the primary tile is inserted first, and then the embedded ones.
Yeah.
It was a minor change. Someone wanted it. I don't think we should ever actually embed tiles because it gets. I would rather you lift. Yeah. I'd rather you lift the individual tiles to separate tiles and then include them specifically in your project.
Oh well, I think watch what I'm about to talk about now, and then see if you have the same opinion.
Yep.
Yeah. Cool. Okay. Thank you. So yeah. So if you're composing tiles, and what we're talking about here is actually jump forward. Yeah. That's it. Oh yeah, no, jump in. Yeah. So in this tile, we've got references to tiles. So this tile has transitive tiles, embedded tiles, and it's a little bit messy. And I don't know what the reasons they have for being messy, but one of the reasons why it's messy is if you stick version ranges in here and you release this tile and people are using it and it aggregates these other tiles together. This tile doesn't have a definition of what these other tiles actually are because they're ranges, so they're kind of fluid. And what that means is that you've got a bit of an unstable system because downstream, if you're using the aggregate tile, you don't necessarily know what you're going to get. And if the build works today, it may not work tomorrow, and you've got no way of tracking it back easily. It's quite opaque, that transition, especially if people go and stick these multiple levels. If either of these had embedded tiles as well,
you obfuscate the range essentially.
Yeah, and so I'd highly recommend that you don't ever do this more than one level, and you're very, very specific about how you go about aggregating them together. And so the pattern that we have is that we have either you use tiles directly or you use aggregations of tiles. And the way that we make them stable, if you jump forward, is that in the POM, what we do is we resolve the versions of the tiles that we want to use in the POM for the tile aggregate. It's not a composition because they're closely coupled and it's pulling specific versions of the things together. So that's why we call it an aggregate as opposed to a composition. And then in the tile, we use a replacement in the square bracket that takes these versions from future resolved at build time and it replaces the tile at build time so that the tile that produced has a fixed version for each of the embedded tiles based on the life cycle of this tile, if that makes sense. Although it probably sounds quite confusing.
Sounds complicated.
Yeah, it's not really complicated. So in this case here, if we built it,
so you just pull the version range out and put it and inject it down there.
Yeah. So at build time, so this might resolve to 2.5 and this one 5.1, and it would replace this with 2.5 and 5.1. And then the tile that you get that you're downloading and using will have the numbers in it directly. And what that means is if you're using this tile and you find that your build changes because someone's done a release and affected something, then you can easily take your aggregate tile, roll the version back, and see if it makes a difference to you. So you've got full control. So you can iterate that backwards and forwards to see where it broke and identify exactly what change it was that happened that made an issue, and then go fix it upstream, or do a retrospective version bump or something to bring it back to the way it was before. So it gives you that control. And because you're not going multiple levels deep, it's not opaque. It's actually quite easy to see. And ultimately, what we've got is we've ended up with a large manifest of tile aggregations, which say all of these little snippets that you have go together in a meaningful group and are used. And you could say, actually, I just want to have fewer tiles which are larger and have the definitions that say, I want to build a Micronaut application that builds Docker and does Kubernetes configurations, all of these things, and runs Jib, and have a big tile that does that. But when you're doing lots, because we're consulting and we're talking to lots of customers and doing lots of different things, that makes no sense for us to have those things because we've got smaller units that we can use. How do you build Jib and make a Docker image like this? How do I build a Micronaut application that compiler will do whatever is needed like this? How do I add Kubernetes resources like this? Bring those together into an aggregate and say, here's how you do a Micronaut application that's using Jib going to Docker on Kubernetes.
Yeah, just really emphasizing that plug and play model, I guess, and that the smallest possible component might be, building a Docker image. The second component might be building out our Kubernetes manifest and from a template. But those two things are going to be common across most of our deployables, right? And that's when we'll put them into an aggregate and ship them as a single tile, basically.
So this is very useful if you're going to be creating all these projects, right?
Yes.
In the scenarios where you have one project and you're not sort of sharing this, you're not working for multiple customers.
Yeah, it's not going to benefit as much.
We've got some examples a bit later on around how we're using the
aggregates.
So in this example, I kind of struggle to see benefit because I see the close coupling, right? But
in this particular example.
Pardon?
In this particular example.
Yeah. So in this example, you kind of list you might as well kind of inject the tiles directly in the plot, right?
Well, yes, maybe. But if you consider,
so you could have several tiles that all refer to the same thing.
Yes.
And then they would all pull only kind of from there.
Okay. So yeah, that's true. And 2 would be uncommon. So imagine that there's 5 there, right? And then this is for Java projects, and you've got 50 libraries. And if you use this tile to define what it means to build that Java library, and then you want to say, actually, we want to move to Java 14 now, you can just release this in one place and update everything. And if it makes no difference, then you've just moved everything to Java 14 and start, right? All of your projects. Whereas if you pull this in individually, then you've got to go and update all of those projects.
Yeah.
So you've got that power to do that.
Yeah.
That's kind of a contrived example, but you see the point. Any more questions before we get on to the gotchas?
So just back on your point there, Seb, about an individual project versus a thing. The other thing is organisational culture, right? Because if I go back to the University of Auckland, there was a culture of developing composites and tiles organisationally. So you'd have multiple dev teams, but there would be communication and a thinking of driving reuse in that sense. You get better value out of thinking about this and doing this if you're across the entire organisation, right? If you're a single individual, no. If you're even a dev team, you're getting less value. If you're doing it more organisation-wide, better value. And that's a cultural thing.
Any other questions? No one online. Yeah. So there's a few gotchas with tiles. There's some properties that don't turn up for POM interpolation at some stages. So there's some things that we use properties where you can't use properties derived from tiles. In particular, values which are used in profiles. So you can't look at properties which are coming from their model in a profile because of when the profile gets enabled. So it happens before. So that's going to trip you up. Just don't use properties. Use other things. Tiles and tiles are difficult and always declared locally to control the order. So apparently there's some changes, arbitrary changes that have happened in the latest release. So things will be backwards now. That might be interesting. I should see what happens with that. When you're defining plugins in tiles, you want to make sure you set the life cycles and you think about them really carefully. So the phases when those plugins run. Because when you're mixing and matching the plugins across tiles, you need to make sure that they happen at the right time. So you need to think carefully about how you do that. Do you do it in the package phase? Is it part of testing? Is it part of process resources? Most of the time, the phases match up and it makes sense just to use them the way they would be naturally. But you just need to think about it carefully and make sure that things align. And mostly, if you've got out of order stuff happening, it's probably because you put a plugin definition in the wrong phase, and that's why it's happening at the wrong time. Extensions don't work in tiles. You have to do those in the main projects because tiles happen after extensions are loaded. And as we were talking about, tiles can be pretty opaque. So leave the boats in the box so you can see what's going on.
Cool. Yeah. Sweet. So I figured I'll show some, I guess, take a step back and from a developer's perspective, when we're actually looking at setting up a new project, looking at setting up a code base, how this would look in the wild, I guess, as we start scaffolding out a new project. So this is what kind of what we're doing at Practive around it, and I'll just kind of step through what each one of these do. So this is an example where we've got a tile that is Chalk Micronaut V2. So Chalk is our, I guess, code name for our aggregates, and you can see what this does on the bullet points on the side here. So we've got build application, the actual build phase itself. We build a Docker image using Jib, as Michael talked about. We've got Kubernetes templates that are push to basically Nexus, and they're pulled down as templates. And we've got a step where we resolve Kubernetes templates, which is great for local development. So we can actually filter using Maven plugins, plug in a whole bunch of developer configuration specific to your just local environment. Don't really need to care about secrets too much, so just plug and play whatever you need. And then we can also enforce compatible project structure. So all of these are actually individual tiles, and they're aggregated as part of that under that Chalk umbrella for Micronaut. So this is everything we need to be able to basically deploy and run a Micronaut project, which is actually really handy. Is there any questions about that in particular? This is an example, I guess, of the extent we've taken this aggregation concept for the purpose of building and deploying Java applications.
Running locally means running,
and for us, inside Kubernetes on your laptop. So we're like Kube native from the ground up. So we've taken this concept and like how we're producing all of these manifests. Basically, we'll have the entire microservice stack running locally on our machines
using K3S or Minikube
or just Docker and desktop, whatever you want, whatever your flavor of the month is. And basically what we then do is I've created a tile called just like a scaffold tile. And what that does is it goes through all of these templates that we get pulled down. And these templates are fairly standardized. We've got our deployment YAML, service YAML. Sorry? Yeah, we can. Yep. But what it looks like for us from a developer perspective, I guess, is I've got like an environment.properties or a scaffold.properties, is what I call it. And what that does is it goes through and looks at these templates, takes a look at all of the possible variable substitutions, and then provides a bunch of defaults for it. So it'll actually go through the same process that we use to actually deliver in the wild to across all of our environments, but then just sort of hijack that, give it a bunch of developer settings, and then run it. So we've got a way of basically throwing up the stack using the same concept end to end, only really mocking what's outside of our service boundaries as a team, and then coming on our project layer, and we've got our stack kind of running up there, and then being able to run this pull down the latest Kubernetes template, substitute in the values, and then throw it into like a live environment where it can interact with the rest of the stack end to end. When you take it away and you say, I'm done with my development mode, then what happens is using the same concept on a different layer is it actually just replaces it back with that production version. So you can kind of just hot deploy things using the same concept. So that's a little bit down the line, I think, and a little bit out of the realms of this. But just as an example of how we're using this tiles concept and this aggregation concept and the links you can kind of take it to. Do you want to talk a little bit more about the resource stuff?
So one of the things that we do is we like to define all of the things that you need as part of the tile in the tile. So a tile project for many of our use cases, like when you say I want to run a micronaut application, and how do we build that with JIT? Alongside that, we also have templates for how that's deployed in Kubernetes. And so the tile project itself has those templates, and they get packaged up as a zip, and the template includes a plugin which downloads those and lays them out. So when you include that tile in your project, not only does it take your code and the dependencies, use JIT to build the Docker image, but it also downloads a bunch of templates, merges that with your local configuration, and then produces a zip which you can use to then deploy that application to Kubernetes. So a tile doesn't just need to be that snippet. It can also be extra resources which you deploy to your artifact repository and then pull down as part of the tile definition.
So when you say you pull it down and it does that, what do you kind of add, kind of build goals essentially to your Maven with these tiles that allow you to kind of push these things?
Yeah. So the POM, for example, would have an assembly plugin which assembled some resources into a zip, and that would be attached as a resource when the tile itself is built. And so the tile produces an XML file which is attached, plus also a zip, plus the jar for the project. And then in the tile, I've written a plugin which is similar to the dependency plugin, the dependency Maven plugin, but it's specifically around using ranges and metadata, so it's a lot faster, doesn't do a lot of resolution in the background, and that will download the artifact. So it will go and download that zip, and it will extract it, maybe filter it, fiddle with it on the way through. And so that tile definition that you release and include knows to download the zip which is attached to the same version as itself. So we do a lot of that with templates and other things where you need to share resources. You define a tile which contains the resources, and they get downloaded automatically into the project.
So this last point here around enforcing the compatible project structure is quite important, because when we're building applications that are Kubernetes native and they're being built using this process, we obviously expect a particular structure, right? And just on that point about being as verbose as we can really with the tiles, what we've done is we go through and we basically say that if a file doesn't exist where we'd expect it to exist, here's the command to create it. So things like where does the application config need to live? So application YAML doesn't exist. We need one of these to be able to actually build this correctly. Fail the build if it doesn't exist. So from a developer's perspective who's coming in and setting up a new project, it's almost like a step-by-step process of just adding a tile. Do I have what I need? No, I don't. Start adding a few things. Looks good, add some more. And it's kind of like, it kind of coaches you through setting up this project in the structure that you'd expect to be able to to go live as soon as you can and start releasing some things. Yeah. So moving on to the next example, I'm kind of just stepping through adding a bunch of tiles here. So this is another example. So we've got this concept of app utils tile, and what this one does in particular is quite simple, but it's a pretty good example where we've got, I think everyone has this issue where you've got a particular log format. I think Warehouse is still using ECS. Yeah, yeah, nice, cool. And we've got the same issue, and lots of people will just manage this logback XML on each individual project layer. What tiles can do is, using this artifact concept that Michael talked about, is basically publish a common logback XML that you want to inherit across all your particular projects. And then what that does is that when you pull this in, is that it will pull, and you can add anything to this really. You can release this logback XML, this particular log format, and then as long as it fits within that version range, whenever that project rebuilds, it'll pull in that latest logging structure, which is quite good.
So the tile itself kind of fires a pull from a side to kind of inject it and merge it into the project structure.
Yeah.
The latest version of.
Give me an example.
Could do.
You find an example. I'm just going to talk a little bit about this tile here. So I'm going to jump back to compositions for a minute. So when we're talking about frameworks like Micronaut or Spring, you end up with this definition of all of the libraries that you need to run an application, and we call those app utils. It's an assembly of libraries that's in a composition, but there's also a bit of code, a bit of glue that sits around there, which says, for example, with Spring, how do you bootstrap a Spring Boot application, or how do you start a Micronaut application? Usually a single line, right? Run this thing with this class path. But you need to put that somewhere, and it's reused everywhere. So we put that in the app utils project, and that's a library that you include in all of your Micronaut projects, for example. So all of our Micronaut things are codenamed Flint. And the Flint app utils is, I've got a standard Micronaut application, I want to run it. This is how Micronaut runs. This is the logger dependencies that are included in it. So all of the logging dependencies are included in there. So if you say, I want a Micronaut application, you include app utils, you get all your logging, you get all the framework stuff that you need, all of the standard things that all of the projects have, not the extra dependencies, but the standard things. But we also make their app utils a tile as well. And that tile includes downloading the logback XML and the other stuff. So where you've got your logging dependencies coming from the app utils, you've also got a tile that goes alongside which says, actually, if you're using these logging libraries, you should also use this configuration. So they go together as a unit. And in terms of the enforcement, when you pull this in, it goes and checks to make sure that actually the dependency matches the version of the tile. So those two things line up. So it fails if they're out of sync. But you get that full unit of everything together in one go.
That's one of the download Maven dependencies on 4G.
But you just have something sitting in like Maven repo?
You can do it later if you want. Yeah.
I can
I'll do it later. Yeah, like another place you can take this concept, which is, I've only started really using recently, is when we're, say, producing a library that requires specific configuration, right? So maybe we're creating a library that handles specific client calls or access to a particular system. You've got multiple applications that need to leverage this, and you don't want to write your client code over and over again across different systems. That's when you might want to create a library, right? And start sharing it across these applications. You can take this concept here and basically apply the configuration or upload an artifact of what application properties you'd expect to have to be inherited by the projects that actually bring this library in. And what this means is that you can actually provide an example snippet of like an application YAML, for example, and then in your project layer, you can merge those application YAMLs so that when we're actually finished with the build, we don't actually have to manage that configuration on every single app level, but rather it inherits it from the artifact that it pulls for the particular tile, which is quite nice, again, from a consistency point of view. A little bit of magic, perhaps, that you've got to learn and kind of get used to, but when you're developing things at scale and you want to make sure that your configuration is consistent across all of these apps, then it becomes quite handy. Let's move on to the next one. Here's another example of what we use this aggregate concept for again, and these are all individual tiles here. So things like code quality checks. We've got a Sonar quality gate there, so it's basically all of, if you've ever used Sonar before and you've ever used Sonar and Maven, all of that standard stuff would be inside that Sonar tile. We use check style, and particular clients will have different check style standards depending on what they're into. And
it's worth noting also that check style tile downloads the check style rules.
Yeah.
So they're always common and shit. And
exactly.
We also did a sneaky thing and copy that check style tile, the check style configuration out of the project and into your global scope so the ID can pick up as well.
Yeah, it's
so
quite
nice.
Yeah, it's quite tricky actually, but quite nice. And it's the same concept as this logback XML, this common logging format. But we've got it with the check style XML. So what it does is, as Michael says, it'll pull it off. We can manage that check style XML, so the code quality for everyone who's building projects, the code standards, sorry, for everyone that's building projects. And as long as, and again, it's version ranged. So as long as they rebuild, what it will do is it'll pull that latest check style into their target directory. And then we do a cheeky thing where we use a Maven plugin to copy it into a common location where everyone's editors are configured to pick up on it. So just by the nature of building projects, the code standards that everybody has and uses in the editors just naturally gets kept up to date as people start, iterating on it, which is quite good. And then we also do some stuff with PII mutation testing, which we're quite keen on lately, which has been proving quite good. So again, like all of you can see how we group these under these aggregates. And if we're talking Java quality, these are the things that you'd expect to have. And you can probably see from this point, especially if you looked at under the chalk micronaut, if we did this individually, there would be quite a few individual tiles there. But because we've got this aggregate concept, it makes it quite clean to like lay out exactly what we need based on these groups of things we might require. Yeah. Just I'm not sure what the PII stands for, but it's basically mutation testing libraries. So what this does is that that tile in particular will mutate your tests and actually start removing lines from your test, and then it'll basically fail your build if you can remove bits of code and your test will pass, which is quite nice because you can see what it's like a step above. You can have 100% line coverage but still fail your mutation testing. So it's like an extra level, and it produces these artifacts that you can actually just view in the browser and see what your mutation coverage is.
How are we going for time? Because it is.
This is the end.
This is the end?
Yeah.
You want to say something?
No. He's got a whole. He's got his own section that he.
Well, I'm wondering. Yeah. Yep. What? Thanks. Why is Jenkins crying?
I just wanted to emphasize that with this, I guess it's been quite cool as a developer to have confidence when you release that things are actually going to go green in CI. Because we can manage this on quite a fine-grained level in the local environment, it's almost like we have a CI environment that can just run exactly like it would in Jenkins on our local machines, and that gives us confidence. Jenkins is crying because he's doing less work, basically, and we can move away from Jenkins whenever we want. We don't need Jenkins.
Pre-commit, right?
Pre-commit, exactly.
Yeah, so I guess one of the main
quality in your repository.
Generating your Kubernetes manifest, building your Docker image, you can do that all locally, exactly like it would work in CI and exactly in the same manner you would to actually start releasing code.
So one of the decisions that we made at the beginning was that we wouldn't get the pipelines defined in Jenkins or the tool to be very smart. We wanted to keep the control in the hands of the developers. And so if you're using Maven for your developer tool, you don't want to learn tools. You don't want it to be building differently. You should be the same. And so it made sense to go, actually, well, this should be based around Maven.
And it's a quality game. I think it's great to kind of increase quality early before it goes into the repository, because then you have the cleanup job to do. And great.
Exactly. I've never seen a greener pipeline in my life because of this, and it's been quite a nice experience, I think. So yeah, shout outs to Michael here for that. That's us, I think. Woohoo! Yeah.
Cool. So I was over with time because it's almost 8:15. Yeah, it's almost 8:15. So. So there are a couple of options. Yep. How's wrapping up or moving this to the next one or continuing? So I've got 2 demos and about 4 slides, and what I can do is just do the slides in 1 second. But do we want to do that? How does people feel? You want to keep going? You want to head off? Look, it's no worries if you want to head off. People have come here though, so I'll probably just do it fast If you got to go, it's no worries. And maybe I can redo it again in the next one as well, and we can go a bit slower on the next one, and I can do a super fast Rob version on this one. Yeah.
Trying to come into Westpac and do it.
We'll see. But shall I just power it through? How are people feeling? How are you guys online? You probably don't care. You're sitting back, chilling.
Yeah, they're at home.
Yeah.
I was just going to say I've put some links to two open source projects on GitHub that are actually common repositories for a whole lot of tiles that get maintained and updated regularly, which was quite cool to actually find random people using this. So
yes, not just Kiwis.
Yeah, not just people I know.
Yeah. Cheers, Mark. And big thank you, because the Maven Tiles plugin has got to be, I think, right up there in terms of the most important plugin that we have in our toolbox. So with that, I have no problem. People stay or go. It's all good. I will.
Can we do
2 minute break. 2 minute break. That'll take me. Yeah. Everyone knows where to go.
2 minutes.
All right. People online. Oh. Ah.
Evening, Rob.
Hey, how's it going, mate?
Not too bad, yourself?
Yeah, pretty good, pretty good. Ooh, I need to, for the first demo, I need to be making sure that I'm running my server using Loom. Otherwise, I'll bash the crap out of poor old Jetty. So I've got that part. And then let's crank this down and crank it down, crank it down. Okie dokie. Run that. Boom. Sugar boom. Boof. Boof. Okay. Yeah, one of these. Is it? Yeah.
Ah, the composites Maven Tiles plugin got a new push just now. Jacoco Maven plugin updated.
Ah, okay. And so people online who don't know, I have a project that uses tiles a lot. It's the eBean ORM project. I've got a tile that does the bytecode enhancement, and it's got an interesting plugin that does enhancement of both source main and source test. And if you don't have tiles, it's quite verbose. Tiles makes that super easy. Here at TWG, we probably have about 6 tiles, actually, not as many as I think the practice guys have got, but we've got, yeah, tiles are a really important part of our build. I'm sharing my screen, so you guys should be able to see my screen. And I got a cool PowerPoint slides thing that we're going to rock through so fast. You'll present
That looks better.
Hey, oh, I better flick this over because otherwise people aren't going to see me do this thing. Plug in darkness. So while those guys are chit-chatting away, you might not be able to hear me, but I'm just going to say a couple of things. So Project Loom, for me, is it's probably the most important thing coming to the JVM in the near future. And fundamentally, the reason is because it changes the way we look at APIs, and it really, to some extent, puts pressure on the arguments about going reactive and reactive style versus staying with the sort of a blocking style and using Loom. So yeah, so to me, it is probably the most important thing from that perspective. I've got a couple of demos, and one of them is a HTTP client, and that is going to use a simple, the HTTP client that's part of the JDK. And we're going to basically beat the crap out of a server, and we're going to swap between the standard thread pool executor service, which is standard threads, and the virtual threads, i.e. the Loom virtual thread executor. So we're just basically going to run the same demo, compare it between using Loom, not using Loom, and what we'll see is that Loom's pretty cool, basically, in a short version of this. And then the second demo is I've got effectively a little wrapper around Jetty. We're going to fire that up, and we're going to basically run it against the normal default Jetty thread pool, which is max 200 threads. The 200 threads is kind of important from the demo perspective. And then we'll swap over to the Loom pool, and we'll run the same load against that server. So that second one is basically, we're going to simulate overloading a Jetty server, and then we're going to flip it to Loom to run the same load, and we'll see how we go with Loom. So that's roughly what we're going to do, and I'm going to try and do it in so fast. Yeah. So how is everyone going online there? Everyone here is definitely not necessarily demobbing, but pretty close to it. Hey, I wonder if I should just start with, and then you guys online can watch it, and then I can just go through it again quickly when everyone else sort of comes back. Is that the moment? Oh, can you see? Can't see. Is that Max's screen? No, this is my screen. As you can see, all those people behind me there, they're just chin wagging. So I'm going to pump through the slides pretty quick. You guys can ask questions, and then I'll do the demos, and then we'll see who's going to do, if these other guys are going to come and watch. Yeah. Prepare to be loomed. Okay, so I've done a little spiel to the guys online. I'll do it again. Loom, it is, in my opinion, the most important thing to come to the JVM. So there's a whole bunch of interesting things coming to the JVM. This is the most important thing from my perspective. The reason is because it really, it will change the way we design APIs. It will change the way we think about APIs. And it brings into the question the old reactive style versus the blocking style and rah, 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 rah. So it's highly disruptive technology for some people, and for others, we've been waiting for it for a little while, and we can't wait to get our hands on it. And so I'm going to try and explain what it is. Yeah, so I'm going to go through these slides pretty quick, but basically we've got a quick slide on what the problem is that we're talking about, what virtual threads are, and we're going to do 2 demos, and then we're going to not talk about a bunch of other stuff that Loom brings. Structural concurrency, scope locals, blah. We won't talk about that. Okay, Loom. Yeah, we've done that. Okay, what's the problem? The problem is a little bit grey, but the general summary is essentially we run out of threads. Where it's the first limitation that we hit when we're running blocking code is we run out of threads. The concept is that a thread takes a little bit too much memory and we get some overhead. So kernel stacks take memory space. By default, that's going to be allocated 1 meg, but it's not going to use 1 meg. So there's a grey area in terms of how big this problem is. It'll vary between app to app. But essentially, the guts is we hit a limit, and the threads is kind of the limit that we hit before we hit other limits like sockets and such. The options going forward, reactive style. So there's a bunch of people out there, you're probably already doing reactive code, and you're doing callbacks. You might have heard of callback hell, rah, 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 rah. And there's the other limitation there, complexity plus should be non-blocking all the way down. We pretty much need it to be non-blocking all the way down, i.e. through to the database. So if you're not, you sort of hit a problem. Just a short version. So you might go from something like netty, sort of event looping, and then you go to blocking code, and then where do you hit that boundary and what happens beyond that boundary. So pretty much, I think this is going to impact everything, including netty, undertow, everything. Second option is Loom, and that's what we're going to go through. There's add virtual threads, and we effectively start looking like non-blocking code effectively. So we start looking like Go routines, etc. And the big ones here for me, keeping it simple, coding style, debugging, profiling, stack traces, everything just works just as it was. And also all the libraries that we use that are blocking we don't care. Third option, stick with what we've got and give ourselves more memory, more pods, right? Third option is absolutely viable, and probably a lot of people are choosing it. Yeah. Okay, what the heck are virtual threads? In short, virtual threads, they implement the thread API. So from an API perspective, they look like Java threads. Essentially, we can have many of them, many of them. And what we'll see is that they're backed by carrier threads. Carrier threads, the short version is in the demo. You'll see virtual threads are backed by a fork join pool based on the number of CPUs of your machine. The second part is probably the key part here. So this part, this looks like green threads in short. And if you're Java 1.1, 1.2, we were using green threads. 1.3 onwards, we stopped using green threads. That's because multi-core came out, multi-core hardware, and basically they decided it was easier and better to go to OS threads. So from 1.3 onwards, a thread in Java was a thread, OS thread. And now we're coming back to the future, if you like, but there's a major twist, this part. So part of Loom is going through the internals and making all of the bits that do blocking effectively yield on a virtual thread. So IO, reentrant lock, thread sleep, everything that we do. Now, there is an exception, which is the synchronize keyword, which won't be in the first cut of Loom. So to be Loom friendly, we need to try and get rid of synchronize. But the guts is that blocking code starts to look like it's running just like non-blocking. We get the same. This, as I mentioned there, you'll see a lot of people talk about the 1 meg allocated stack. It was a traditional thread being part of the problem. And yes, it's a little bit more complicated because, yeah, it's allocated, but it's probably not used. And in reality, we need to profile to see how much of memory we're going to use per thread. So it's not just a simple 1 meg. It's something between, I don't know, and 1 meg. So we're going to crack into a demo. Yay. What I'm going to do with this demo is I'm going to use the HTTP client. The HTTP client is built into the JDK. We're going to basically swap between those new fixed thread pool and a new virtual thread executor. So first one's the Loom one. Second one is just the standard JDK. We're going to hit an endpoint. It's got a 20 millisecond response time. We're going to see lots of virtual threads. We're going to see them backed by carrier threads based on fork join pull. We're going to see them yield, and we're going to basically compare to fixed thread pull. So let's crack in there. If I can find the right place to go to. Oops, missed. Yeah, okay. So short version is I've got some code here. Right. What does this do? I'll just show you quickly that we go and fire a task. This task is going to do an HTTP GET. So if we go in here, we see it's going to do an HTTP GET against an endpoint, nothing flash. We're going to spit out how long that took and the fact that we got HTTP 200 responses, rah, rah, rah. And we're going to fire this, and we'll run it 10 times. And we're going to go run. So what I'm going to do is try and explain what the heck this demo is and what it's about. So roughly here we see we ran HTTP GET 10 times. We're getting our sort of 200 odd millisecond response time. And the important part here, we're seeing that it's using a single thread, right? And we're taking about 2 seconds to execute. As part of this demo, I spit out in sys the old number of platform threads that we're operating with. So when we run with Loom, we'll see that that is based on the extra 12 platform threads that are the carrier threads, the backing threads. So let's just set this up a little bit here. If I run this with 10 thread pool 10, we'll see it run in parallel, and we will get all of those executing in parallel 10 requests. Okay, so that's pretty straightforward, no problem there. Okay, so it's banging up. Let's increase it by 10, run it again. So now we're going to do a linear type of scaling, right? So we've got 10 threads in our thread pool, executing 100 requests. Now we're taking around 2 seconds. Okay. Now what I'm going to do is just flip this to 12 just for kicks. The reason why I mentioned 12 is because 12 is the number of threads that we're going to use when we're using Loom, because the backing thread pool of Loom is based on fork join pool, based on the number of CPUs on my laptop, which is 12. Okay, so we end up with the XC milliseconds of around 2 seconds, you know, just a little bit quicker than 10, right? Okay, flipping over to Loom and hitting the X and running it. Okay, so we went a lot faster. Why did we go faster? Because I cheated. Yes, I cheated. Why did I cheat? What happened there? Okay, so we're running them. What you'll notice here is that we've got virtual threads. Actually, I've created 100 virtual threads, right? So before we had 10 platform threads, it was 12 actually, and now we've got 100 virtual threads, and they're backed by the fork join pool. We can see that, you know, that's, for example, worker 8. What we'll see is here worker 12. We won't see anything more than worker 12. We've got 12 carrier threads backing our pool. Okay, so what happened there was that we ran our request using virtual threads. The virtual threads blocked, but they yielded, and so we were able to run all of this load using those 12 threads, but we're actually able to go faster, right? So if we flip that back, so how fast did we run there? 300 milliseconds, right? Now if we run with, deleting the wrong thing there. If we ran with just normal 12 threads, right, we've got our linear scalability, and we're going to run in our, you know, 1.8 seconds type situation. Okay. So we're going to still use 12 platform threads because they're the carrier threads, They're the ones using our memory. But now we're going to run with Loom. We're running actually a lot more virtual threads, but we don't care because virtual threads are cheap. And now we're running a lot faster. Okay. Questions?
This new virtual thread executor.
Yes.
And executor stuff. Where does that come from?
Oh, JDK. This is all JDK that you're seeing here. JDK is, this is Java 17 early access build. This is part of the JDK. This is part of the JDK.
Right.
So let's explain here. Let's do this. So what we're going to do is we've got 100 requests. We've got a thread pool of 100. We're going to run it. It should run fast, right? Now, yeah, so now we're executing about the same time, right? But instead of using 12 platform threads with virtual threads, we're using 100 platform threads, right? So this is why we care, because at some point we start hitting a limit. Now, is it 100 threads? Maybe not. Maybe it's 1,000. Maybe it's, whatever it is. But at some point we start to hit an issue. So if
you're running a whole pile of pods on one server.
Yes. So, I could scale this demo up, but essentially the thing here is that we've got a linear relationship between the number of requests I'm processing and the size of my fixed thread pool. So now if I go 1,000, I'm going to go 10 times slower, about 2 seconds, right? If I flip over to Loom, run it. Okay, I'm going to fire 1,000 virtual threads. They're going to use the 12 underlying platform threads. So I'm not using 100 threads, I'm using 12. And did we go faster? I think we did. About the same? Slower. Oh, yeah, we did go slower. No, there we go faster. You got to run it twice. But the thing I was going to say here is that we've got a linear relationship, right? Let's crank it up. So we've got our linear relationship between our thread pool size and our requests. So I guess the thing that I'm trying to say here is that we've got this relationship which will hurt us at some point, and we've got two approaches for dealing with this. One is to go reactive, the other one is to go Loom. Loom is going to be very easy for us because we're literally going to go, I'm going to swap out my thread pool.
Or
so
in most cases, you're just going to upgrade your framework library and it's just going to be fine.
Yeah, exactly. So now we flip over to virtual threads. Can we run it in less than 20 seconds? Drum roll. No. Yeah, we got there. So I'm going to run it again because why not? And then I'm going to show you something slightly interesting. But so let's talk about that and just summarize. So we ran it with 100 threads. We ran about 20 seconds. That was expected. That's our linear degradation, right? And then we flipped over to our virtual threads and we ran it again, and now we've run it in about half the speed. And we've only used 12 carrier threads. So we've used about 1/8 of the threads, and we've gone a lot faster, right? So there's a pain point, and we could hit it, and at the moment we might just give it more memory, more CPU, or more pods, and then the alternative is to flip the Loom and go better. So this is going to be pretty interesting because now we care less about blocking. I don't necessarily care about making my HTTP call out because I know I'm not going to block that thread. I'm actually just going to block a virtual thread, and actually it's just going to yield onto the work onto the carrier thread. All right. Happy with that? Questions?
That's awesome.
Sorry, what? So I'm going to give you two little reasons. One is that what you'll notice here is you've got a funky thing here going on, right? So these numbers really ideally should be around 200 milliseconds, and they're not. And I can't really explain that. What I'm going to do is I'm going to run this thing. So Park Nanos is literally going to do a 80 microsecond sleep. Now, what I'm doing is what we're actually running is we're using a platform thread to then put a whole bunch of tasks onto a virtual thread pool. But I want you to watch that left-hand column there. And what you'll see is those numbers are around the 200, right? So that's kind of well behaved. That's what I hope a demo would show. But it doesn't when I chuck truckloads of requests from a platform. I don't know what's exactly going on. Hey?
What do you call it? What do you think?
Well, what's at the other end is a Jetty server running Loom on my laptop.
So you're
right?
overloading.
No-ish. Second demo is banging the crap out of the Jetty server. I don't believe I'm overloading it.
The network box is probably going to overload.
It could be. There's a potential for it. The other thing is that this is an EA release. Maybe it's something else, but I don't know yet. So watch the space. Maybe I'll see if I can figure it out one day. Question over there. Yeah, I do. I do a warm up. I hit it twice. I go get. Oh, sorry. Hang on a second. What?
So the fixed thread pool you only run once, right?
Oh, right. Yeah, this is as reliable as the church, mate. Well, that's actually that's probably a bad analogy. This is reliable. This is reliable as my Subaru. No, that's another. No, this fixed thread pool. You can almost guarantee that is going to be 20 seconds plus or minus a few minutes.
You have to run it twice in a row.
You have to run it twice in a row.
You're demanding sods. You want me to run this twice?
Yes, because then you kind of can compare it.
Oh well, I think there's many variables, so I wouldn't be. That's one.
Yeah.
You want another? It's gonna be the same.
It probably is.
That's all right, Seb. No, it's all good. It's all good. That's Seb, not that Seb. So, yeah. So, oh shoot. Oh, well, no. That's slightly unfair because I've got the Park Nanos. Yeah. So, the Park Nanos, right? If I don't need that for the traditional thread pool. It behaves very nicely without the Park Nanos, right? What I noticed was that I can get really nice behavior with the Loom virtual thread pool if I have the Park Nanos in it because I'm not overloading something. What it is, I don't know. Yeah. Happy? So I don't know if there's anyone online looking at questions and stuff. Should I fire over there quickly? Or should I just go into the server stuff? Have you guys got any questions? There's something in there. Blah, 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 blah. Are virtual threads in the main JDK 17 build or are separate? No, it's a separate. You go to the Loom page, you get a Loom build you can download that's got this stuff in it. I don't know about the standard JDK 17, but no, I don't think Loom is in the JDK 17 mainline. So no other questions, probably. I'm gonna go back. Now we're gonna go to. Oh no, sorry guys. No, blah, 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 blah. I'm going to go to quick slide that talks about what the server demo is about. Got a library that's basically Jetty, and we're going to swap between using Loom and non-Loom. So the non-Loom default Jetty thread pool is 200, maxes out 200 threads. That's a key factor for this demo. We're going to do an HTTP GET, hitting that, hitting an endpoint. We're going to use a tool that's going to show us how well that behaves. So we're going to overload the server. And that's no good. Got to go back to here. I've got to go to my server and turn off Loom. This is the output here. Just note that this output is the number of threads that we're utilizing. We'll look at that later. No, that's not the right thing. This is the right thing. Okay, so I've got a server. It's a pretty simple endpoint. Let's speed it up. Going to use tool. I'm going to request. Oh, can't probably see it, but it'll scroll up. 10,000 requests. Clients 100. Hitting this endpoint. Go. So this will scroll up. So people hopefully will be able to see it. We can make it bigger if we want. Now the critical thing here is the 200 threads of the server. So what it is 100 is less than 200. So we're not overloading our server. Our server is going to be happy. And if we look at happiness in this form, we're looking at these two things here. Firstly, fastest and average in particular is around the 200 milliseconds. So it's pretty well behaved. And we can see that with our histogram, pretty well behaved, right? Our histogram is all banging in there, right? Now, okay, we've got time. 190. Gosh, I'm losing the old voice here. Yes, I have a cup of tea. 190. Gosh, that even sounds worse. 190 is still less than 200. So we're still getting pretty decent response. And our histogram's still pretty cool, right? Good enough. Was it even better? There you go. What happens if I go just a little bit over the old 210, right? So what we're starting to do now is slightly overload our server. We're going to get some what I'd call jitter, where we are now going to see that distribution get worse. And we're going to see some stuff go up, right? So now we've got our average pumping up a little bit, and we're starting to see some negative distribution of our responses, right? So we've kind of gone over. Well, let's cut to the chase. Actually, let's significantly push it. So we've got 50,000 requests. Yeah. That's true, actually. Eh? But our 500 is more than our 200, so we are definitely going to give it contention on the back end, and so we're going to see our distribution go a little bit less than happy. Anyone got a joke? No, it shouldn't be taking too long. But what we'll do after this is we will flip to a Loom thread pool.
And then sort of dates on the official stable release.
Well, yeah, I work for Oracle, and I'm going to give you no. Oh, okay. So what I've heard is that let me answer that after I talk about this. So we got kind of, I guess what we expected, right? So we happy with this? Is there sort of questions? We've overloaded it. So now, now our average up here, 481, and we're seeing a kind of a bad distribution in the sense of less happy performance, right? Less happy server. Okay, let's fire the same thing, but let's flip our server. So flipping that and restarting. Oh, before I do that, by the way, we're serving these with 219 threads total, right? So our 200 threads going to Jetty, or allocated. Now flipping over to our virtual threads with backed by our fork join pool. So how many threads are we going to probably max out on this side this time? It's going to be less. Hang on, whoa. What's that? That wasn't the request we did. This is the request we did. What's happening now is we're going to create more virtual threads on the server side, but they're going to be backed by many fewer threads on the actual server, so our 12 carrier threads. So we're hoping for that. Demo worked quickly, run away. But this is pretty bloody cool, isn't it, for an EA release? Yeah. Now, caveats, of course, I've made this demo to illustrate this issue, right? But it does show what's in store for us. We're literally going to be able to take this. So there's a few things going on, right? One is that we've got a potential even if we're using reactive, right? We've got a potential boundary between going between reactive and blocking, unless you're going blocking all the way, right? So we're talking about R2 DBC versus JDBC, rah. But the concept here is that if we wait a little bit, maybe even not very long, we're going to get some magic shit, basically. Our JDBC drivers are now non-blocking, and we are now no longer going to have this window where we worry about overloading our server. Our server is going to behave actually nicer, even under real high concurrent requests. It's going to be pretty cool. And
that's what makes it now for you scaling applications. I would say, have you seen any sort of CPU graphs between those two different executions? Like, is this actually showing less CPU usage on the Loom?
I haven't looked at that in particular. What I've looked at is going, how high can I go? I go to 700, and then I start running out of sockets, so open files, file descriptors, I should say. So, and of course, this is a laptop, and I'm running on myself. There's a lot of areas where this demo is not what you call super duper robust. But at the same time, I can flick one parameter, which is Loom, no Loom, and I can kind of get the behavior that I'm expecting on both, and it's pretty impressive.
So, from a future perspective, is that something that will be kind of? Is it something that people can need to choose essentially explicitly to use versus kind of? So
Yeah.
It's always the executive kind of
yes.
involved to decide what way you want.
Yep. Okay. So the question is, would we try to would we use it? Would we opt in? Is there things like that, right? So kind of the answer is, firstly, Loom's going to do nothing for us if we're all CPU bound. So if we're doing CPU intensive stuff, right? Loom's not doing nothing for, right? So where we're in is in the IO, server space, client space, talking to databases in that space. I'm going to give you my opinion. So my opinion is that this will be, people will take this into account. So even if you're, if I think about the server space in a number of different stacks, right? So they've got the Jetty stack where we have a thread pool and literally we swap it out, bang, where.
That's a property.
Well, yeah, it's a property in my thing that's changing the thread pool, right? That's a slightly different thing because it has a slightly architecture where the pool is just the workers. That's a slightly different architecture, say, to Heleden microprofile edition, which is based on Netty. So Netty is if you like, an async orientated thing. So it has a worker pool, right? So it's got a dispatcher thread, a worker pool, and then you come out of that and you go, actually, what is the rest of the stuff? Is the rest of the stuff non-blocking, or am I going to swap to blocking? And if you swap to blocking, you're going to put that work onto a different thread pool, and that thread pool is probably going to be a Loom virtual thread pool. So what I would say is, I think this will probably impact the server stacks that I think of because of that boundary between going to a blocking code. So it won't impact people who are non-blocking all the way and they've got their reactive hat on and they're reactive, to the core. Those people will go, nah, not interested, thanks. They've got all the callback stuff. They've got all of the, their issues, and that's cool. They've bought into that. Anyone who's going to that boundary, yeah, Loom is going to play a part. So, for example, in the Quarkus space, and I think in the Heleden microprofile space, they're both going to Rest Easy or Jersey. They are going to go to blocking from non-blocking to blocking, and that will be, I'm going to say, a Loom pool. So at some point, they're going to have that same config property, yeah, in my opinion.
So the question is also about kind of retrospectively kind of unblock some legacy code, for example.
Yeah,
without really changing the code itself.
Yes.
Will you be able to kind of switch to virtual threads from physical threads with minimal, let's say, source code invasion?
No source code invasion. None.
No code.
Yeah. So what we need is the libraries to be Loom friendly. To be Loom friendly, they need to today current state not have the synchronized keyword. So some people, I guess like me or other people, need to remove the synchronized keyword from the bits that we care about. For example, the Postgres JDBC drivers, various bits. All my stack is Loom friendly now, except for those Postgres JDBC drivers. I need to try and push that in. But so from that perspective, the impact is, hey, you need this particular version of the Postgres JDBC driver. Now, by the way, your stack is Loom friendly, and you just change that thread pool out for config or whatever, and then bang, you're going to go faster and lighter. Yeah, probably.
So in terms of removing the synchronized, what was involved in doing it? Because you lost all concurrency protection.
Oh, you swap out synchronized keyword with a reentrant lock. So a reentrant lock is, yep. Yes, yep.
So I'm looking at Loom, which is truck tracking software, and it works like normal trucks to hold the data to the service, and we were redoing the service and get stuck with like a traditional approach with the thread pools. And then we had to go reactive and kind of heavily break the microservice into very, very simple bits so that we keep the API bit non-blocking.
Yep.
So it's not doing anything, just throws things at Amazon. It's very, very scalable. It's very reactive. So nothing except for the last code is actually blocking. That was a big thing to write. Like if we could have thrown something like this virtual thread executor instead of normal thread executor, probably would have been solved by one line.
Yep.
So we spent a couple of months rewriting to React.
And once you'd rewritten it, how complicated was the code mental where you made them simple?
We had to switch to lifestyle from Dallas. It was like a couple of weeks for the whole team just trying to understand the new concept. So give some time spent learning tools. So yeah, I'm pretty excited about it.
Yeah.
I add a different example.
Yeah. Yeah. For us, I mean, we've got a particular service we need to bump up. It's through 300. But that's okay. You know, it's cheap and easy, right? In relative terms, in terms of effort, in terms of real cost, it's probably the cheap option, right? So yeah, and I think from the perspective that I have, yeah, waiting for this to come, and I guess from me, the focus would be to get ourselves into a position where we can take advantage of Loom as soon as it comes, because it's going to be interesting.
And in terms of wider ranging impact on the industry, I mean, Java already leads the performance space in terms of web service and all the other things. This puts it that far ahead that people are making decisions about technologies in terms of Python, PHP, other things actually go, well, actually, the difference is getting big enough that maybe we need to reconsider what we're doing.
Yeah, exactly. So I'm not sure if you guys heard that, but probably at the Go people will say, hey, we've got Go routines, blah, 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 blah. And the thing about this is that this is responding to that. But then in the language space, as I see it, we'll have languages like Go and Java, which will be this approach. And then you'll have all of the other languages that pretty much have an async keyword or something like that. So there will be a boundary that says you're this type or you're that type. I mean, we already kind of have that. And that's already existed with Erlang and other things like that. But we will be on that side of the fence. Yeah, to me, the nice thing about it is that lots of stuff that we see in terms of our code, in terms of the simplicity of it, if then else blocks, try catch blocks, it's all like linear. We will still see code like that, and we will get the benefits and performance of reactive without actually having to write it. So it's massive. Yeah. But yes, like for me, I think unfortunately for us, I think we're still not in the cool kids zone, right? Java with this Node.js and these are the cool kids and rah, and there's just truckloads more of them than us, seems to be. I don't know why that is. I'm old fuddy-duddy. But yeah, I think our runtime probably doesn't get the kudos that it deserves. And part of it is also the complexity that we've put around it. Like I'm thinking, Spring and rah as complex. I mean, you'd argue it's not complex, but it's built a lot of weight. And so now we have this reputation of being weighty and heavy and slow, and our threads are expensive and and well, this is really going to put the cat amongst the pigeons, especially if you add in the code generation style for other things that we might talk about in the future, like DI and all these other things, right?
But honestly, Java has been dragging its heels a little bit on kind of innovation and kind of making it easier for a developer as well.
Oh yeah.
I mean, look at functional and kind of thing. Look at, I mean,
I think
simple things like string blocks, right? That have honestly, for ages, right? And it will make things so much easier.
It's true, and I'll put my hand up. I was in that boat. So you think Java 8 took forever to come out, right? And then we had lambdas. But the future was, I don't want to say bleak, but the future was not looking that flash, right? So you had people,
Java was behind.
Yeah, and so what we were looking for is not necessarily a different runtime, but a different language. So hence I got super interested in Kotlin and rah. Yep.
Even earlier when it started to kind of do stuff with the JVM that I never could have imagined.
Yeah. I didn't. But where we're at now is a different place. It's very different from then. In terms of the iterations of releases, it's truly ironic that the JVM is firing out releases and we can't keep up as developers. 16's out. We're not up to 16. I mean, this is This is really the boot. Eh? Yeah, 16's out.
Is it LTS?
Yeah. Oh, is it LTS?
So
No.
still 11 is LTS, right?
Oh, well, it depends on how you view it, right? Well, yeah, okay, it's a different story, but I don't see it.
There's a problem with enterprise because they just.
Yeah, I don't know. I don't kind of see it that way, but yeah. But what I do see is that the boot is definitely on the other foot.
Yeah.
And you know, we kicked the crap out of Oracle in terms of but they've done a great job in bringing that up. And now it's our job to catch up, and we better catch up fast because Loom's going to be cool. Yeah.
I mean, that's the kind of thing where you bring that out in the new LTS and then everyone just moves to it. Because you can justify the bottom line and say we're running 10,000 servers,
yes,
and we can turn that into 5,000. And the exec's like, you're going to save how many millions of dollars?
Yeah, yeah, and it's true, right? Yep, exactly. Yep. So you know, for us, it's get prepared. Try and get to 16. 15 is easy from 11, I think. And then 16, they've changed some defaults on the, so it's a bit tighter. So you have to bump plugins and all sorts of interesting stuff. But yeah, get ready because it's going to be. The other aspect is that if you have this in mind, you're probably pushing back on certain approaches to certain things, right? Because you're saying in 6 months' time, what we're doing now is not going to be the ideal. So I certainly, for myself, I'm looking at libraries that are orientated towards Loom in the sense that, you know, they're blocking, you know, yucky blocking, but they'll be cool when Loom is cool. So think for the future, and because it's going to come soon. It might not come 17. Seb asked, did I think what I've heard? What I do know is that I think they're one of the tricks in Loom is the yield, the cost of yield, right? So basically, what they're doing is popping stuff off the virtual stack, the stack, putting it to one side, and then when that virtual thread and the carrier thread are put together, they're putting it back on. So park and unpark or something like that. So the cost of that was being swapped out, I think, from what I read. So in other words, they're tweaking that part of it, which sounds kind of like 17 is probably not an option. 17 is not far away now.
Yeah, but then there's 18 just around the corner.
Exactly. I'd guess 18. But you know, maybe I'm optimistic. But 18 is not far away. Sorry, Lou, online people. Kind of ignored you. How are you all going? Here you are.
Pretty good.
So, any questions for the audience here, online people? You're very polite. Aren't they all devilishly handsome?
There's beer. There's cheese.
Plenty of beer and cheese.
All right, and then I haven't even looked at the questions. There's probably I don't think there's any in the chat, and no, I think we're all good, aren't we? Yeah, no, I think we answered that one. Right, it's me. Demo.
Yeah, thanks very much, Rob. Really interesting.
Yeah, no worries.
And thank you very much for taking over the job.
No worries. All good. Okay, well, I think we can let everyone online go and have your whatever it is, hot chocolates, and we will partake in sayonara and catch you later and see you guys. Cool. I'll stop recording.
Thank you, Sam.
Cool.
Thank you. Bye.
Right. No worries. I'm presenting and still recording or something. Don't know what the heck. Is that? Stop recording. Oh, maybe I didn't hit the button.